Our next speaker is BrahMos Dr. A. Sivathanu Pillai, Distinguished Scientist and Chief Controller R&D in DRDO. He completed his BE in electrical engineering from the same college where I also did my BE, but 3 years senior to me, so super boss in the college. Then he subsequently joined the Space and Science Technology Center, Thiruvananthapuram, and after some few years working in the various launch programs, he moved to DRDO in the year 1986 and participated in the Integrated Missile Development Program under the leadership of Dr. Abdul Kalam, who was our former SA to RM scientific advisor, as well as our former president. And everyone knows him as the missile man. Actually, he is now supersonic missile man, not just a missile man. And in addition to all his activities, he also led to the development of many societal needs and the spin-off from the DRDO technology. Mainly, one of the major things where he worked and then made it possible is to produce the lightweight calipers for nearly 30,000 polio-affected children. Then in the year 1996, he was appointed as the Chief Controller R&D in the DRDO headquarters. So he became my super boss in the DRDO headquarters later. And he held many positions there. And for a short duration, the work which I am doing it today, he was doing it as additional charge in addition to his technical activities. And he conceived the joint venture program, BrahMos in India, which is successful today. And with this joint venture approach, DRDO and Russia, Government of India and Russia joined together. And then now that missile, almost every services have placed numerous orders. I think it is going to something like multiple thousands of crores. Rather, it is 10,000 crores, much beyond that. He has published many papers and received number of awards. I can't read all the awards because there are too many. He is the fellow almost in all the societies. But he is also the honorary fellow of the Association of Minimal Access Surgeons of India. For an engineer to become a honorary fellow in a surgeon associations, something fantastic. And he is also a fellow in the International Project Management Association, PMA. He is going to talk about a small change in the title of the topic. He will be talking about technology leadership through collaboration to match with the theme of this Aero India Seminar 2011. Dr. Pillai, please.
Dr. Ilavagan, fellow speakers from MIT, SOB and the ADS, distinguished aero and space specialists, DRDO and ISRO colleagues, Air Force officers from the Air Force and industries, distinguished guests, students from the aeronautics community who have come from many colleges, and friends. I am indeed delighted to stand before you to share my thoughts on the main theme of the international seminar, and also to highlight how a collaboration can lead to success and how we can create a role model. Just to recap, because there are many foreigners here, I thought I should tell them about India. Just to recap, this is what the curve shows, India's prosperity dynamics. If you look at this early years, before 5,000 years I am talking, India was the origin of scientific thoughts. Many of the scientific thoughts, you talk about algebra or finding zero or pi or anything in mathematics, trigonometry, all have originated from India. Medicine, surgery, astronomy, you name anything, the great scientists were here at that time. If you talk about Newton's law, it has been initiated 500 years before Newton. but it is there in the records. Like this, we go through our ancient history. It was a very big scientific country. Knowledge was the capital. Great universities were there where people studied from other countries. And in the last 2000 years, we have seen invasions after invasions, and that reduced the prosperity. And during the British regime, we did not participate in the Industrial Revolution, which became a very important component of the economy. Our population also increased, agriculture came down, so the poverty started coming in. Poverty will eat away the knowledge. And after independence, the first attempt from the government was to see that India builds up as a country where you can feed the people. That was the first attempt. Then engineering industry started coming in. Slowly we built. But the revolution came when the information age knocked at our doors. All the population, which was a curse earlier, became suddenly assets, and India's economy started climbing up. Now we are in the knowledge age. Knowledge and technology is going to rule the world. If that is so, there is a great opportunity for India again to take the leadership. What we need is global leadership for India. We have all the resources, natural resources, biodiversity, human resources. So India can definitely become a great nation. If you look at the economic growth in the societal transformation, we clearly see when we are transformed from agricultural society to industrial society to information society to knowledge, India has potential for growth through knowledge-based human resources. And what is our human resources? We have 540 million youngsters below 35 years. Many universities, many colleges have come. Highly qualified professionals per year we are producing, more than millions. And it is the second largest English-speaking population in the world, so we can go anywhere and work. So the whole analysis of the world, analysis shows India tops in terms of quantity and quality of manpower in the years to come. And we have to produce a global human resource cadre with world-class skill and higher education with research, because the research is the basic component which will generate more knowledge. So these are the two important areas where we should concentrate in developing our skill. Then the skill will lead to support in the economy, in manufacturing, services, and also in the knowledge-based products and systems. If you look at the economy today, India tops is one of the 12 countries in terms of the GDP, and steadily the GDP is growing. There are some variations in between, but things are looking better. The industry is more than 9%, services more than 10%, and the average, the cumulative average growth rate is above 8%. With this economic growth, India is today, this is the status of the economy in 2007-8, but now in 2020, this is the scenario which has been expected, that China will overtake USA and India will become third country in the overall global economies. That means India has got a great future. But we have to be more competitive. In the future, it doesn't mean that everything will come to us. We have to work for it. So that we are in a competitive world. In this competitive world, whatever we make, aerospace product, whatever we make, that should be competitive. What is competitiveness? If you look at it, there are three factors in the competitiveness. One is product excellence, performance, quality and reliability of the product should be supreme. It should be cost effective, and it should be available when it is required in large numbers. That means production capability should be there. Product excellence means newer technologies, quality procedures and certification. Then cost effectiveness is continuous improvement of the product with minimum cost, effective life cycle management, value engineering and cost control measures. Availability in time means we should have necessary production infrastructure with trained manpower, then contractors management, enterprise resource planning and supply chain management all become very important. If we can be comprehensive in all the three aspects, then the product will be excellent. What is needed for a product to be excellent? We look at the knowledge base, that's a design base. In a product life cycle, it has got specification, design, process, manufacturing, servicing and product improvement. This is the life cycle. We try to put the contribution of various elements in terms of value addition. How the value of the product is added, you see design dominates. We look at the quality curve. Again, the design dominates. What is design? Is the knowledge. So knowledge, that is owning the knowledge, that's what we call it as a self-reliant society. You need the design knowledge which will dictate cost, quality, reliability and producibility. So owning the design is very, very important. But why did we go wrong then? These are the dimensions of technology in product realization. So our first Indian approach. We look at the technology, it means research, development, technology transfer, technology absorption, production. These are the elements of the technology. Ultimately, we want technical performance, quality and cost effectiveness. Now, there are three ways of looking at the technology. One is called license production. We have gone ahead initially with the license production because we didn't have all the knowledge with us. So, what does it mean license production? We get the fabrication drawings, production process. We don't know how that is designed. So limited know-how and knowledge acquisition. Know why is not there. Then high life cycle costs. Then industrial growth only in the low technology area because we don't get the high technology. Anybody who transfers the technology will give only second-rate technology. Then other option is to go through the indigenous R&D. You know that we have started all our technology development much later than what the Europeans and the Americans have done. And so that means indigenous technology development will take, we will be only following them. But in the process, you know the know-how and know-why, knowledge acquisition, low life cycle cost because it is in your command, growth of main and allied industries in high technology areas will grow. But only thing is it will take more time. But you know, you have the knowledge with you. Other option is go for technology collaboration. In selected areas, indigenous R&D and limited collaboration, make a product, then sharing of development effort and cost, you are sharing with another country. Then faster realization because the thing which you don't know, you are getting it. Then you can go for global competitiveness if the product is good. Look at these curves. This is the technology level in the world. If you follow A, you are getting again all the time the low technology, you are going to be having a divergent status. That means in terms of technology level, you will be far behind the world level. If you go for B, the gap will be more initially, but there is a chance for overtaking if your technology is good. But in the C route, definitely there is an opportunity to cross the world because you are putting the best efforts from multiple nations. That's collaboration. These are some of the examples I have put. License production, MiG-21 I have taken as the example. Then indigenous R&D, Agni is the example. And technology collaboration I have taken BrahMos as the example. Now, if you go for the route A, this is some of the things, some of these products which have come in the route A. As a built large infrastructure we have built, manpower, trained manpower, but what we lost is indigenous design capability. Competitiveness index is very low because outdated technology, customer looking for newer product, but the newer product means product improvement is required. That means the design knowledge should be with you, but which you don't have. Life cycle cost is very high. And underutilization of infrastructure as the product is phased out. As the product getting phased out, you will have underutilization of your infrastructure, what you have put. This is what has happened in the case of technology transfer. Some of the examples are here. Suppose you go for indigenous development, these are some of the examples of indigenous development. MBT Arjun, LCA, P-17, that's a ship. We built the ship, Navy built the ship, then the airlights or LAX. These are indigenously developed, but with certain collaborations. For example, Arjun tank has got imported engine drive system. Then Tejas, you have got the imported engine. Then P-17 is a warship design indigenously built, but only thing is it has taken enormous time and cost overrun. Airlights again design capabilities certain. Now it has got export thrust also is there. It's one of the good examples. They have collaborated in design, engines procured. So if you look at this competitive index, the various things have got different index. That is, research can calculate this type of index based on what is the component which has gone, what is the technology we have developed. But it looks that indigenous development, though it takes time, but finally it gives the capability to the country. Now come to the missile development. IGMDP, this is also indigenous development. This what you are seeing is the world's first rocket, first war rocket. It was developed in 1792 war. It was used by Tipu Sultan. And this war rocket is a 2 kilogram gunpowder rocket with a sword, and he used more than 6,000 of these rockets against the British cavalry and defeated them. So the video what I am just showing, it is taken by the Britisher, and he is telling in that video that the British lost the war because they have seen some unknown object coming towards them, and they got terrified. So this became the rocket technology in the future. And India, of course, for after 1792, the whole place was destroyed, and we have started our program only in the 70s, and in 83 we started the Integrated Guidance Missile Development Program. At that time we analyzed where we are, we stand. We stand with nearly 20 years of technology gap. There is a constraint of technology flow, MTC or Missile Technology Control Regime was in the offing. Technology moves very fast because it's military, and the user requirement gets changed. These are the constraints. But we have some experience. We have got put together the national strength and then try to look at the new technologies. So the technological objective was, when we develop this in 10 years time, there should be contemporary performance at the time of deployment. Otherwise our user is not going to take. Multi-role, multi-user concept should be used. So you have got the 3 users, Army, Navy, Air Force. You don't lock on 1 user, you try for 3 users. Quality and reliability should be built in the design, and it should be cost effective. So the major requirement is futuristic technology and the design adaptability, and make the customer as part of the whole program. So that has led to development of many things. I am not going to discuss all the details to you now, but I am only just highlighting based on the theme that one of the examples indigenous development is the Agni, which is the audio not working. I am trying to highlight to you one example that we have when we have to design the shape of the Agni re-entry heat shield, which needed enormous computing time and good software. It was not available, and we don't have the internal facility for hypersonic testing during re-entry. So what we have done is we have adopted CFD codes, computational fluid dynamics codes, and new codes, and we were looking for developing a supercomputer. We know that it is going to take time. Nearly 100,000 points have to be analyzed, and each point with conventional computer was taking 9 days. So we were looking for a supercomputer. Of course, it was denied. When it was attempted, it was denied. Then we put a group of 14 young people to develop the supercomputer by ourselves. With Dr. G. Venkataraman's leadership, we developed the PACE Plus, which was a 32-node hypercube system, which was 20 times faster than the Cray XMB, which was refused to us. In 24 months they developed. So this has broken the monopoly of some of the countries to dictate technology collaborations. And also we developed the software, and very advanced software. With the software and hardware together, we found out that the 9 days time for each iteration was reduced to 5 minutes. So this is one attempt which has really showed that the capability exists in the country, but it has to be tapped. Another important requirement for the Agni was the carbon-carbon technology, because it's a re-entry to be proved, and it needs the development of the carbon composite shield and with their carbon-carbon nose tip. This is a very, very guarded technology because they are meant for the re-entry and it's used for the ICBMs. So nobody will give the technology. So that's we developed, and we organized teams as a consortium for the multi-directional weaving and brining technology, then matrix densification process, evaluation in the kinetic heating simulation facility, all these things, but group number of institutions, that is academy, industry and R&D organization together as a consortium, broken down the technology into small packages and then started developing each element and slowly built in 3 years time the complete technology of re-entry. Today the re-entry technology is with us. So these two examples of Agni shows that we can do even very difficult technologies in this country. So if you look at the Agni, that the result, if you see, design capability has been built, we can realize longer range strategic systems, that means country has acquired the power, critical technology like re-entry acquired for the country, managing with multiple institutions and experience in managing complex missions. What is lost is taken much time to establish critical technologies where everything has to be done by us, and but competitive index is very high because we have become a strategic country. Similarly, there are a number of technology like re-entry, the sensors, guidance control, seeker systems, our own processor and the supercomputer, super components for the electronic warfare systems, then phase shifter for multi-target engagement for the Akash, our own foundries for gallium arsenide and silica, then multi-function radar for the Rajendra radar, phased array radar, and then 3D central accretion radar, propulsion systems. Many things have come, underwater technologies, all have been denied to us, but we have developed everything. So technology denied has been gained. So with this background, the world was looking at India. Oh, these guys know technology. We have to be with them. And as the economy grows and the demand is there for the country, market potential is there, the West started looking at it as collaborators, not just as sellers. So this is what during this 90s, early 90s, we saw the Gulf War. We heard about the Gulf War. And one of the important components of the Gulf War is the Tomahawk missile. This missile was launched from the Persian Gulf. Very accurately they fly at a very low altitude and very precisely they were destroying the targets. Whatever we have planned in the IGMDP, there was no cruise missile. Then we thought this is a very important component to be developed and it can become the first strike weapon. Because nearly 1,000 Tomahawk missiles are launched to eliminate Iraq's assets. So this is going to be a very important requirement. Then how do we develop the cruise missiles? Then we analyze the world, all the world people are having cruise missiles with a speed less than the speed of sound. So in order to overtake others, we thought we should go for supersonic speed, and then we need to collaborate with the Russians for the supersonic engines, who readily agreed to collaborate because our technology in the guidance and control which they have analyzed, they found it is much superior to them, so they decided to collaborate with us. So this is called technology collaboration. That is two nations joined together, put their technological assets and then try to make a product which is superior to what is existing in the world. There are difficulties like their culture, language, their expectations. Joint venture is not an easy thing to do, particularly with different countries, because we have to maintain the win-win situation throughout the project. But if we can do that, it will become a big breakthrough for our nation. So India and Russia joined together, put their resources together, capabilities, core competencies shared, and the BrahMos Aerospace joint venture was registered in Delhi with 50.5% for India and 49.5% for Russia to undertake joint design, development, manufacture and marketing. That means from mind to market we should do. That's a whole range of work must be taken up by this joint venture company. That was the initiative, and we shared the work like inertial navigation system, OBC, onboard computer, fire control system, platforms, and the engine, the so-called engine, was given from the Russian side. And this is a type of share we have done, $250 million, which was later increased to $300 million for the aircraft version also. And we have gone for design, which is universal design, with multiple platforms, warships, mobile launchers, submarine, silos and aircraft, and multiple trajectories, different types of trajectories, different environment, different targets. It's a single system. That was the concept. Nowhere it is existing in the world. A similar concept also. So this is what we have done in for the Navy. Audio. So this is what we have developed for the Navy. We have developed inline as well as vertical launch missiles as an anti-ship version and anti-land version. It also can do from land to ship as a coastal defense, and we have tested number of times. We showed 100% successful results in all the naval flights, and the Navy was very happy to induct in their ships. Similarly, for the land version, land to land for the Army. So a number of regiments have been created for the Army now, and the Air Force also is taking the ground systems which will be inducted in the next year. So all three services are going to have the BrahMos system, and the Air Force wants that to be launched from the Sukhoi, and we have already developed the new variant of the missile which can fly from the Sukhoi aircraft, and also the new launcher prototype is ready. All work is now in progress. We want to fly the missile from the aircraft next year. So if you just see the approach we have taken, we went for supersonic. So subsonic versus supersonic means what? Not only the speed is 3 times, that means you can hit the enemy at 1/3 time, and the kinetic energy is velocity square. So 9 times you will be able to give the kick. That means the destructive power, and the target dispersion also is less in the case of moving ship, so the homing accuracy is far better, and the reaction time given to the enemy is less. So in a war, these factors very important, and particularly when there is cruise missile defense, supersonic cruise missile, particularly with stealth characteristics, it is very, very difficult to intercept. So next 20 years, I don't expect anybody to intercept BrahMos. And our approach was from the very beginning, thinking about the operational version. So we went for total concurrency, design, development and production. And the short time we have taken, within short time we are able to produce and supply to the 3 services. Is a unique success factors, is exclusive brand character through market promotion and international exhibitions, proactive strategic decision and actions at the right point of time, joint working in teams between the 2 countries, scientists from different labs working on a common platform on an umbrella organization, and multiple production centers in both the countries have been created, user interaction at every stage. That was in the concurrent development, production and induction. And many industries from India as well as Russia have been named, have been through MOU, they have become partners, and we have made an industry consortium. And we have kept up the schedule, and sometimes early we have completed the task, and we are now concentrating on the air version and underwater version and induction in the Air Force. And the original scope was only anti-ship version, but we have done the additional thing, ship-to-ship, ship-to-shore, land attack version, with now the Block 3, the new version is ready. So many things have been developed with the same development cost, because we have reduced the number of flights because of success. And air-launched missile system under development, limited production capacity. Now we are augmenting the capacity to large enough to support the armed forces and quality assurance in precision. So the project successfully completed within time. I am talking about the scope-wise for the Army and Navy. A high-performance, cost-effective weapon system realized. India possesses the most potent weapon system for precision strike. Is a force multiplier in network-centric warfare. India becomes a global player now, entering into a new paradigm of export of weapon system. We invested 300 million, but still money is available. But our order booking is 4 billion, and we expect to cross $10 billion order. That is the profile of the collaboration. It has become a globally competitive product. With the concept, can we leapfrog brand? Can we establish brand? That was the concept. We had the innovation, speed, precision and power, which is dictated by the future war, became the innovative ideas. Then the creativity, novel JV concept, one step higher than the state of the art technology. Then leadership, thinking ahead and managing complexities. Best practices, simultaneous R&D and production management and industry consortium. Then technology, resources sharing, experts. And finally we got the product, which is a highly demanded product by Indian Armed Forces and by many other countries. So BrahMos has become a global product. This is what is competitiveness, which I explained to you in the beginning. So not only that, India has today, after the IGMDP has come, we have got strategic missile systems, both Agni versions and Prithvi. We have got attack weapon, cruise missile attack weapon BrahMos for multiple platforms. Then we have got ballistic missile defense, which is in the final stage of experiment, and number of tactical missiles. So self-reliance has been achieved in missile technology. So we are now looking at the Sudarshan Chakra, like what Krishna has with him, to go and come, eliminate the enemy and come back. That is the hypersonic speed. That's our next target. So if you look at the India's foreign policy, economically we have progressed, manpower is good, ideas are good. If challenges are there, we are the first people to show our strength. And policy also is very good. Today you have got the foreign policy makes things much easier. You look at the IPSA forum, South Africa, Brazil and India, there's a connectivity created. Look East policy, Asian countries, SARC and BIMSTEC in the neighbor countries. Then India, UK, EU defense committees, India, Israel, I2MC, India, Russia, ELTP, long-term project program, joint ventures, understanding in GLONASS, common youth satellite being launched between India and Russia. Then with the US, the civil nuclear policy and JTG. I think every country we are now engaging to see that we become a very important player in the world. Why? We want to build a strategic partnership with other countries, defense cooperations, joint military exercise, technology collaborations, free trade agreements, then tourism exchange program, joint economic ventures, training programs, all have been launched to see that India becomes a global nation. Integration of core competence of every nation through collaboration results in extraordinary output. So we have to use the other country's strength to our advantage. Ultimately, what we are looking for is win-win situation. We don't want another country to be the loser. We don't want to be the only winner. So it should be win-win collaboration. That is what is required for our nation. Thank you.
One question, please. Yes. Only that particular row.
Sir, I have two questions for you on the BrahMos. The first question is, what are the kind of secret technology used for land attack?
Secret technology?
Land
I
attack
don't
mode?
want to talk here.
Okay.
You see, so many people are there. You know that.
During the
During tea time, you can talk to me.
And other question is, for the long range application, do you think the supersonic technology of BrahMos will be feasible and cost effective?
Yes. We can do that.
We
We will not only supersonic, hypersonic technology is feasible for long range. Say 5,000 kilometers, you can do that.
Thank you.
Okay. Yeah. Please. Mike, please.
Hello, it's George Mada from Military Technology Magazine and also speaker about weapons today in the afternoon. A question to the air-launched version you mentioned, which is in preparation. We always hear that this will carry it on the center station between the engine, the Su-30. But there's also talks that about a special batch of Su-30s which can carry two of them. How is the status?
No. Presently, our plan is to use Sukhoi 30s which are being produced in our country.
Yes.
They are producing at Daichel Nasik. They are for a particular configuration. In that configuration, we are going to put at the center. One.
Okay. For the moment, no other.
No.
Thank you.
Thank you, Dr. Pillai.